Hi, I'm Teresa.
Hi, I'm Safi.
Hi, I'm Frida.
Hi, I'm Callie, and we are going to show you how to do limiting reactant calculations.
Hi, my name is Teresa, and today we're going to discuss limiting reagents. My problem that I'm going to be solving for you is number 73 out of our textbook. So the first thing we need to talk about is what a limiting reagent is. My best understanding of what this is compare baking chocolate chip cookies. You have a whole lot of ingredients, but you only have so many chocolate chips to make your chocolate chip cookies. So let's say you have 1 cup of chocolate chips, and you have, doesn't even matter how many other ingredients you have for eggs and flour and just the batter in general. If you only have 1 cup of chocolate chips, that you can only make 1 batch of cookies. So the chocolate chips are going to be the limiting reagent, or the limiting amount of product that we need in order to make a certain amount of chocolate chip cookies. In chemistry, just like in real life, there's rarely the exact amount of substance you need to make an even amount of product. So to do this, we're actually going to do an equation on the board for you. First, you're going to have to do with the limiting reagent problem, and ours is if you have 50 liters of hydrogen chloride gas and it reacts with 10 liters of oxygen gas, how much chlorine gas will be produced? So the first thing you have to do is have your chemical equation. So I have 50 liters of hydrogen chloride plus oxygen gas to produce chlorine gas and water. We have to balance this because we don't have enough. I wrote it over here already that on the reactant part, we only have 1 chloride, 2 O2, and then 1 hydrogen. Well, on the product, what we've produced is 2 chlorine, and 2 H2Os and 1 oxygen molecule. So it's really simple. All you have to do is go back and forth to balance each one out. So we'll start with HO2. We have right now 1 O, and you have 2 over here. So if you put 2 in front of the H2O, that'll balance out your oxygen molecules. And then for your hydrogen, now you have 4 hydrogen molecules. You're going to take the 4, go back over to your reactant part. Now you have you only have 1 hydrogen, so now we have 4 hydrogen to balance these out. And then now we have 4 chlorine. We're going to go back over here. See, you have 2, but you're going to put a 2 in front. 2 times 2 is 4. So now you're going to have the 4 chlorine here, 4 chloride here, and now your whole equation is balanced. So that's the most important thing to do, so you can figure out exactly. You're going to have to take the 50 liters of hydrogen chloride gas and plug that into your equation, and then the 10 liter hydrogen oxygen gas, and do 2 separate equations to figure out your limiting reagent. So now I'm going to show you exactly how to do your problem after that. So now that we've balanced out our equation, we have to see what the question's actually asking us for. So our question now, we're trying to find how much chlorine gas each one of these reactants can produce. So after I wrote down our balanced equation here, now the first thing we want to do is take our 50 liters of hydrogen chloride, plug it in the first part of the problem. It's just basic math at this point. So we're going to times that by the 2 Cl2s over 4 HCl's. You always want to have your HCl's, if this is where it's at that you're asking for the question, and then you want to have that at the bottom because we're trying to convert to fine chlorine gas. So the HCl's are going to cross out, and now you're left in the Cl2s. So you're going to times 50 liters times 2 over 4, which is actually going to leave you, that's basically half, and that's going to leave you as, we have produced 25 liters of chlorine gas. So you're not done yet. After we've done that, you have to go down to the second part, because so now you know you've converted your hydrogen chloride gas, you've made your chlorine gas, but now you need to find out your oxygen gas, again, to find out how much of 10 liters of oxygen gas will produce chlorine gas. So now you're down here. You've had to write out 10 liters of O2, so you've plugged that in, and then you just do your basic math, so you're timesing that by your 2 Cl2s over your O2. So you're going to cross out your O2s, so now you're left in chlorine. So you have 10 liters times 2 equals 20. So you now have 20 liters of chlorine gas and 25 liters of chlorine gas because of the hydrogen. what this means is, now that we've figured this out, it's a 1-to-1 ratio because we are doing a volume to volume in gases, that 20 liters of chlorine gas is the most that you can possibly make, and 25 is, you can only take 20 out of there. So we have 5 extra liters of chlorine gas that's been produced by the hydrogen chloride. So that also, so in conclusion, the oxygen gas is the limiting reactant, and the hydrogen chloride is the excess amount that you have. And then that's how you solve the problem.
All right, we have 2 objectives to focus on today. The first is to define what a limiting reactant is, and the second is we need to know how to determine a limiting reactant from this problem. All right, so a limiting reagent is the reagent which prevents another corresponding reactant from fully being utilized. All right, for example, we have 10 hot dogs and only 5 hot dog buns. In total, we can only make 5 hot dog sandwiches, which means that the buns are the limiting reagent and the hot dogs are the excess. All right, so let's do an example to solidify this concept. Okay, so we've been given 40 grams of iron 2 oxide, which reacts with 10 grams of magnesium. And the question is asking us to find what mass of iron is produced. All right, so first of all, we have 40 grams of iron, and which reacts with 10 grams of magnesium oxide. All right, and it's asking for the grams, how many grams of iron. Okay, we have 40 grams of iron 2 oxide, which reacts with 10 grams of magnesium. So the next question we ask is, how many grams of iron do we need Okay, so we start with the iron oxide and we solve for the iron. And in order to do that, we take our given, which is 40 grams of iron oxide, and then we find the atomic weight of iron on the periodic table. So we have the atomic weight of iron added to the atomic weight of oxygen. And together they make 71.85 grams. So we want to cancel out the grams of iron. So these cancel out, and we're left in the units of 1 mole of iron. And now we want to convert from 1 mole of iron to grams. Right, so the moles of iron cancel out, and we're left with 55 grams of iron. Right, and then, which is where we want to be. We want to know how many grams of iron we'll be left with. So then we do we divide 40 grams by 71 grams of iron oxide, and then multiply by 55.85 grams of iron. And then that leaves us with 31.1 grams of iron. So we found our first thing. Second, we start with magnesium, and we need to solve for iron. So we have 10 grams of magnesium, and we want to know the molar mass of magnesium. So we cross this out. We start with our given, of course, and then we cross that out, and then now we're in moles, and then now we do the molar ratio, which these cancel out, 1 mole over 1 mole, and then we're left with 1 mole of iron, and then we need to find the molar mass. So then these cancel out, and then we're left with we find the atomic weight of iron, the atomic mass of iron. Atomic weight of iron, okay. And then that gives us 23.0 grams of iron. So looking at these 2 results, we can tell that the limiting reactant will be the 23.0 grams of iron, and the excess will be this. Right, so to recap, we went from mass to moles, and in order to do that we had to use the molar mass, which we refer to the periodic table. And in order to go from moles to moles, we use molar ratio. So for example, this equation is already balanced, so there's 1 iron oxide, 1 magnesium, and 1 magnesium oxide and 1 iron. So the ratios are pretty much equivalent, but if we had, for example, 2 iron oxides, iron oxide compared to the iron would have 2 moles of of iron oxide over 1 mole of iron, for example. That's just an example. All right. So once we went from moles to moles, we did moles to mass, which we use molar mass. Thank you very much for listening. Goodbye.
Limiting reaction is like a recipe, and for example, I have 3 slices of cheese and 2 breads. So out of 3 slices of cheese and 2 bread, I'm gonna make I have to make a sandwich. But the bread is gonna limit my work to make a sandwich, which means I can just make 2 sandwiches. So bread is gonna be my limiting reaction. And the example and the question I have is mentioned. It's same as the example I mentioned. So the equation, I'm gonna balance the equation first before I start anything, because it's obvious the equation is not balanced. I have 1 aluminum here. I have 2 aluminum, so I'm just gonna put 2 aluminum here, and then after that I'm gonna balance SO4, which if I put 3 here, I will have 6 oxygen here and 6 hydrogen. I'm gonna have 6 hydrogen here, 6 hydrogen here and 6 hydrogen here. Then I'm gonna put number 6 here, which I'm gonna have 12 hydrogen here. So I'm balanced with the aluminum and hydrogen and sulfur, and I'm balanced with the oxygen as well, because I have 6 oxygen here and 6 oxygen here. So for balancing I'm okay, and now I'm gonna start doing the finding the reaction. And the first question is about if I have 1 gram of aluminum hydroxide react with the 3 grams of the sulfuric acid, what is the mass of the water produced? So I have 1 gram of aluminum hydroxide, and in order to just go to the through the solve the equation, I have to get the mass of the aluminum hydroxide, which is I'm going to find all of the aluminum, oxygen and hydrogen out of the periodic table, and add all of them together. I'm going to get 78.01 gram of the aluminum hydroxide, which is going to be 1 mole of aluminum hydroxide is equal to the 78.01 gram of the aluminum hydroxide. So they're going to, the gram of aluminum hydroxide, they're going to cancel each other, and then we're going to go mole to mole, because I want to compare, I want to see how much aluminum hydroxide has water. So now I'm going to go for mole to mole, and because I want to compare aluminum hydroxide to see how much water is in the aluminum hydroxide. So I'm just going to write my water, and then so the water has 6 moles, and aluminum hydroxide has 2 moles, and because I want to know how much, just calculate the water, so the water is going to go in the denominator, and then after that I'm going to find the mass of the water. I want to know how much is the mass of the water, because I want to know the end up to gram of the 2 gram, to see how many gram water is in the aluminum hydroxide, which is going to be 80. Then so I'm going to find 1 mole of the water, is 18.02 gram of H2O. So I'm going to times all of them, the denominator together, 6 times 18.2, and then whatever I got, I'm going to divide it with the denominator, and then I'll get the I'm going to get the 0. Yes, so now we're going to look for the 3 grams of the hydrosulfuric acid to see how much water is in there. We're going to do the same process for the aluminum hydroxide we did. So we're going to go first, we're going to find the mass of the sulfuric acid, which is going to be which we're going to write there like a hydrogen, how much is the hydrogen in the periodic table, how much sulfur, and okay, and so we got the mass of our sulfuric acid, which is going to be 98.09 gram, and then so which means 1 mole of the hydrosulfuric acid is 98.90 gram, and then after that, when we get the mass to mole, we're going to get mole to mole, which means because we're looking for the oxygen, how much water is in the sulfuric acid. So we're going to put water in the denominator and a mole of the water in the denominator and a mole of the sulfuric acid in the denominator. And then after that, we're looking for the mass of the water. So we got mass of the water. The answer, when we times all of them and divide with this, I'm going to get 1.102 gram of the H2O. So this one and this one, it's telling me aluminium. We have aluminium has 1 gram of the aluminium produce 0.692 gram of the water, and so aluminium react to the 0.693 gram of the water. This is the limiting reaction.
So you guys are probably wondering what a limiting reagent is. A limiting reagent is the substance which is totally consumed when the chemical reaction is complete. The amount of product formed is limited by the reagent since the reaction cannot proceed further without it. So for example, imagine you are having 4 people over and you're going to play a video game, but you only have 3 controllers. Your ratio of controllers to people is 1 controller per 1 person. So if you only have 3 controllers but you have 4 people, only 3 people can play since there are only 3 controllers to give out. Therefore, the controllers are the limiting product because they're what limit the maximum number of people from playing the game. So I did number 69 in chemistry in our textbook, which says that if 70 milliliters of nitrogen gas reacts with 45 milliliters of oxygen gas, what is the volume of the nitrous oxide produced? And you're to assume that all gases are at the same temperature and pressure. So the first thing that we have to do is look at the equation that the book gives us. As you can see, it's not balanced because on this side there are 3 oxygen and on this side there are 2. So you have to think, what is the least common multiple between the 2 and 3 oxygens? Which would be 6. So we have to balance this out to get 6 oxygen here and 6 oxygen here. So we're going to put a 2 here to get 6 oxygen, because 3 times 2 is 6. And then we're going to put 3 here, because 3 times 2 is 6. Now we have balanced oxygens. But our next problem is that we now have 4 nitrogen. But we only have 2 nitrogen here. So we're going to put a 2 in front of the nitrogen over here to get 4. And our equation is balanced. Next I'm going to show you how to solve our limiting reagent problem. Now that we have balanced the chemical equation, we are going to convert the milliliters of the first reactant to the milliliters of the final product. And in our case, our mole conversion is in milliliters because that's our base unit. So what we're going to do is we're going to take the 70 milliliters of the N2 gas and we are going to convert it into the N2O3. So we have our 70 milliliters here times our 2 milliliters of N2O3 because that's our 2 moles over the 2 moles of N2. So the milliliters of N2 cancel out and it's just basic math from here and you get 70 milliliters of N2O3. Now we're going to do the exact same thing with our second reactant. We are going to take our 45 milliliters of O2 gas times our 2 milliliters of N2O3, which is our 2 moles, over our 2 milliliters, or our 3 milliliters of O2, which is our 3 moles. And the milliliters of O2 are going to cancel out, and then it's just basic math again, and we get 30 milliliters of N2O3. Now, as you can see, our 30 milliliters will be our eliminating reactant because it can only produce that much nitrous oxide instead of the nitrogen, which can produce 70 milliliters of N2O3. So, to recap, our limiting reactant is our O2. Okay, so just to recap, here are the steps for calculating limiting reactants involving the volume of gas. First, you're going to balance the equation. Second, you're going to figure out what you are solving for. Then you're going to convert the milliliters of the first reactant to milliliters of the final product. Then you're going to convert the milliliters of the second reactant to the milliliters of the final product. And then lastly, whichever reactant produces the least product is the limit. Thank you.